So after plugging in the values of a, b, c, and d, you can see that the graph has been transformed due to it being stretched vertically, compressed horizontally, and shifted right and down. So after looking at how these points are shifted on the graph, we can deduce that the domain and range must also be transformed like the points are. So from this, I began applying transformations to the domain and range of the original graph. So in order to do this, I divided by the compressions and multiplied by the stretches, and then added and subtracted the appropriate shifts to the domain and range, with the domain being the x, the horizontal shifts, and stretching and stuff, and the range being things that are vertical. So then I get this resulting graph with the restricted and the new domain and range. So then I did about the same process for arcsecant, and even though the domain and range involve infinity, we just don't regard that because these transformations would be meaningless, and we simply apply it to each of the parts through multiplication and addition, division, and subtraction, and then we get the new domain and range for the new function. Now, after looking at both graphs, it is obvious that the two graphs have the same maximum and minimum values. This is due to the fact that if we look at the original graphs, at pi, their maximum, both of the graphs would start repeating again, and that would mean that they are in a function, as they would fail the vertical line test of functions. And this happens for the same thing in secant. These graphs would begin repeating themselves. So this is the same reason that they have the same minimum value, as they would start repeating down, just like cosine does in the original graphs. Now, in regards to the asymptote that secant has, this is because both do involve cosine, but at this point, this asymptote, arc cosine would be equal to 0, and while that is fine in the arc cosine graph, it is not fine in the graph for arc secant, as this would be 1 over 0, which is undefined and therefore an asymptote. Now, in regards to domains, the domain of arc cosecant is within the undefined gap of arc secant. Now, this is due to the fact that in the parent function of arc cosine, -1 to 1 is the domain. As cosine is the ratio of an adjacent side over hypotenuse, and that ratio cannot be greater than 1, or the adjacent side would be greater than the hypotenuse, which is not possible. Now, arcsecant is the exact opposite, because in this case, it's the flip of cosine, in a sense, and that would mean that we are talking about a ratio that is the hypotenuse over the adjacent, and being under 1 does not make sense, because that would mean, again, that the adjacent side is greater than the hypotenuse. So, yep, that's pretty much it, but the values in the function follow the same rules, only with transfer values to meet the adjusted graphs.